Hello and welcome to the Reigate College Maths Further Mechanics 1 video on momentum and impulse. So we're going to introduce some new quantities today that you will have seen from your work in physics at GCSE. So we've got momentum, which is mass times velocity. So the units there are going to be kilograms and meters per second. And it's very important to say that momentum is a vector quantity, so it has direction. We've got another quantity we need to look at, which is impulse. And impulse is equal to force multiplied by time. So impulse is force multiplied by time. And it turns out that impulse is equal to the change in momentum of a body or a particle. So that's the final momentum, take away the initial momentum. Impulse, because it's equal to force times time, the units for that are Newton seconds. So that's Newton seconds multiplied together. These two are equivalent units. We can quite easily show that impulse is change in momentum using Newton's second law. Let's have a go at doing that. Force is equal to mass times acceleration. And we know that acceleration is equal to change in velocity divided by time. So we've got force is equal to mass multiplied by v minus u over t. So multiplying both sides by 2 here, I get force times time is mv minus mu, which is change in momentum. So if the momentum of a body changes, a force must have acted. I'm going to look at a couple of examples here. These are not in the course workbook, so just sit and watch me go through these and then we'll do the examples from the workbook. So here we've got a 5 kilogram mass resting on a smooth table. A horizontal force of 4 newtons acts on the mass for 6 seconds. So a diagram here shows before and after. So this is 5 kilograms and it's at rest to start with, so it's got no velocity, and we're interested in the velocity at the end. So first of all, we're going to work out the impulse. So impulse is force multiplied by time. So that's 4 times 6, which is 24. Impulse is also equal to change in momentum. So we're going to say that impulse, 24, is equal to the final momentum, which is 5v, minus the initial momentum, which is 5 times 0. And that gives me that v is 24 divided by 5, which is 4.8 meters per second. Notice that we could do this using Suvat equations and Newton's second law. So we could say force is mass times acceleration. So 4, which is the force, is 5 multiplied by a, so a is 0.8. And then we'll use Suvat. U is equal to 0, a is equal to 0.8, t is equal to 6. We want to find v, so v equals u plus at. V is going to be 0 plus 0.8 multiplied by 6, which is 4.8. So we get exactly the same answer using a different method. Always reassuring when that happens. Third question we're going to look at here is a ball hitting a wall. First thing to notice, we've got a ball of mass 250 grams. Notice that that's non-standard units, so we're going to say that is 0.25 kilograms. It travels at 30 meters per second and hits a wall. So that is 30. And it rebounds, so it bounces away from the wall with a velocity of 20. Find the impulse exerted by the wall on the ball. So that's going to be in this direction. The wall is going to push the ball away. So we're going to say impulse is change in momentum. We need to be very careful about direction here. We're going to take that direction as positive, so away from the wall. So impulse, which we're trying to find, is equal to final velocity, which is 20 multiplied by 0.25, minus initial velocity. Well, the initial velocity is minus 30 multiplied by 0.25. Because this is a negative direction, we have chosen that direction to be positive. Working this out, this is a quarter of 20, which is 5, minus 7.5, so the impulse is 12.5 Newton seconds. And it acts away from the wall. Let's look at the examples from the course workbook now. We've got the information at the top here that I've already been through. So the first question, find the momentum of the truck, 3 tons, moving at 0.3 meters per second. So we're going to say that's 3,000 kilograms multiplied by 0.3, which is equal to 900 kilogram meters per second. So just be careful to change your units correctly. Question 2, we've got a body of mass 2.5 initially at rest. A horizontal force of 6 newtons acts on the body for 2 seconds. So we're going to think of before and after. So here is before, a mass of 2.5 and it's at rest. Afterwards, we've got a velocity there and it's still got a mass of 2.5. So first of all, what's the impulse? The impulse is force times time, so that's 6 multiplied by 2, which is 12 seconds. Part B, the final speed of the body. Impulse is change in momentum, so that's going to be 2.5v minus 0. So V is 12 over 2.5, which is 4.8 meters per second. Final question, we've got a ball hitting a wall. So we're drawing the wall. The ball approaches the wall with a speed of 3.5 and it rebounds with a speed of 2.5. The mass of the ball is 0.2 kilograms. Now the question is, find the impulse exerted on the wall by the ball. Now, the easiest way to think of this is that whatever impulse the ball exerts on the wall will be equal and opposite to what the wall exerts on the ball. Because action and reaction are equal and opposite. So that's what we're going to do. We're going to take this direction as positive, and we're actually going to end up working out the impulse on the ball. So impulse on the ball is going to be 2.5 multiplied by 0.2, that's its final velocity, minus 3.5 multiplied by 0.2. And when we work that out, we get 1.2 Newton seconds. So that's the impulse of the wall on the ball. But the impulse of the ball on the wall will be equal and opposite. So there will be an impulse of 1.2 Newton seconds in this direction into the wall that the ball exerts on the wall. But the question only asks for the magnitude, so we actually don't need to worry too much about the direction. We can just say that the impulse is 1.2 Newton seconds. So the key point with these questions is to make very clear which direction you're taking as positive, and look out for this sort of expression where you've got a negative, subtracting a negative.